What's up? This is Dr. Taylor Krick, host of the Autoimmune Doc podcast. And on my YouTube channel here, I review papers from the peer-reviewed scientific literature that are associated with some of the things that I talk about on the podcast, some of the mechanisms of autoimmunity, some of the lifestyle recommendations or natural botanical recommendations or things like that I make on the podcast. This is the evidence behind those. So a lot of studies that we review on this channel, again, are associated with autoimmune disease, but not all of them directly. So even this one, has certainly an autoimmune component to it. But we're talking about the gut microbiome as a major regulator of the gut-skin axis. So some skin conditions like acne or eczema or psoriasis, very, very common skin conditions, and how the gut is associated with those skin conditions. This comes from Frontiers in Microbiology. It was a review paper. It's published in July 2018. So the adult intestine hosts a myriad of diverse bacterial species that reside mostly in the lower gut, maintaining a symbiosis with the human habitat. In the current review, we describe the advancement of how the gut microbiota communicates with the skin as one of the main regulators in the gut-skin axis. We attempted to explore how this potential link affects skin differentiation and keratinization, and how to take advantage of this communication in the control of different skin conditions. So the clinical relevance to this is that if you have a skin condition, it's very, very common in the dermatological world you've got to put something on that, right? The problem's on your skin, so you've got to take a steroid cream, or you've got to rub something on that, or whatever the case may be. But the point of this is that in functional medicine, oftentimes there are other factors leading to the outward presentation of symptoms, but they could be coming from inside. And it's common in functional medicine that we start with the gut because there's so much evidence towards this. Now, I don't always start with the gut. I don't follow any guidelines like that, like always start here. Every case is unique, and we take a very customized approach to every case. But the point is that the gut matters to a lot of different things, to neurologic diseases like Alzheimer's and MS, neuroinflammatory diseases, but also psychiatric diseases, depression, anxiety, PTSD, and also skin conditions as well. Not to mention, typical autoimmune diseases, Hashimoto's, rheumatoid arthritis, things like that, but even some of the skin things and brain things and things that are, a little bit further away from the gut. So here is, some of the things that we're talking about. And I'm not going to go into all of it, so I'm going to skim, quite a few of this. But here's what we're looking at is that skin homeostasis and skin allostasis, which is like skin stress versus the maintenance of stress, are all linked to the gut microbiome, and so is skin dyshomeostasis. So if you have skin allostasis and skin or homeostasis and allostasis, but if you get dyshomeostasis, which is just an imbalance of peace, basically, it leads to psoriasis, atopic dermatitis, and acne. So the role of the gut microbiome in skin homeostasis, it goes through this. This is very, pretty deep paper. It's a review, so there's a lot of different citations and things in here. I'm not going to talk about all of them. Though not yet fully explored, the mechanisms by which intestinal microbiota exert their influence on skin homeostasis appear to be related to the modulatory effect of gut commensal bacteria on systemic immunity. Certain gut microbes and metabolites promote the accumulation of regulatory T cells, lymphocytes, which facilitate anti-inflammatory responses. So that's just talking about how the gut, some of the mechanisms again. Now, let me go to the diseases, because that's where I wanted to talk about mostly. Let's go to acne. So acne, three primary factors are implicated in its pathophysiology. Approximately 85% of people have acne. And this is personal to me. It was a long time ago, but I had acne, and I took Accutane, which a lot of people my age were on Accutane, especially if you're in kind of your mid 30s, early 40s, and even it's still used, but yeah, and there's now these class action lawsuits with Accutane leading to certain, I believe, like inflammatory bowel disorders and things like that. So, da da da. Acne is particularly prevalent in Western countries. Talking about high glycemic load, high carbs, insulin. Talks about mTOR. Where are we at with that? So gut microbiota influence the pathophysiology of acne via crosstalk between the gut bacteria and the mTOR pathway. So mTOR is a metabolic pathway, a cellular metabolic pathway. It stands for mammalian target of rapamycin. And it's really hard to explain. Metabolites produced by the gut microbiome have shown to regulate cell proliferation, lipid metabolism, and other metabolic functions that are mediated by the mTOR pathway. What this is saying is that this is the mechanism. The mTOR pathway can in turn affect the composition of the microbiome through regulation of the intestinal barrier. In cases of intestinal dysbiosis and disrupted gut barrier integrity, so dysbiosis and imbalance of good and bad bacteria, disrupted gut barrier integrity, leaky gut, this bidirectional relationship can result in a positive feedback cycle of metabolic inflammation. And that's what drives mTOR in the pathogenesis of acne. So this relationship serves as a mechanism by which the gut microbiome can influence acne pathophysiology. So again, it talks about other, components with anxiety and depression, psychological stressors, other things. Talks about some of the inflammatory responses. But yeah, that was the main sentence that I wanted to go through. Here's another one too with SIBO. And this is more GI dysfunction, but hypochlorhydria, so low stomach acid, very, 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 very common. Hypochlorhydria is frequently associated with acne. Low levels of acidity allow for the migration of bacteria into the small intestine. These bacteria translocate from the large intestine to the small intestine, creating a state of intestinal dysbiosis and SIBO. I talk about this all the time, and it's something that we measure. It's something that I see so commonly. Hypochlorhydria associated with it, antibiotic usage, oral contraceptives, stress, vagal nerve, just decreased motility. But SIBO, where these bacteria overgrow in the small intestine, they ferment certain foods, and it leads to big problems. And it says this here. A larger bacterial population competes for nutrients and impairs the absorption of fats, proteins, carbs, and vitamins. Malabsorbed nutrients, including folic acid, B9, zinc, chromium, selenium, omega-3 fats, have been shown to influence one's psychological state, and along with systemic oxidative stress, have been implicated in the pathophysiology of acne. SIBO also results in the production of toxic metabolites, which can damage the gut, damage enterocytes, increase leaky gut, and ultimately lead to systemic inflammation. Now, I see this all the time. Again, and it often leads to fatigue, hormonal imbalances. Bloating is the hallmark sign or symptom, but there are others. But SIBO is a really, really, really big deal. So I wanted to highlight that with acne. Because it's a little bit more specific than just the gut microbiome is important for your skin. Here's atopic dermatitis. So this is itchy, eczema type allergic, like itchy pruritus in the skin. Talks about just how it happens. But then it says the diet microbiome theory implies the increased prevalence of allergic diseases stems from a less robust state of immune homeostasis rather than from an over-response to environmental cues. So the gut microbiome and the immune system just isn't shutting down these responses. It's not that the responses are so aggressively inflammatory and tissue damaging, but it's that there's just not good regulatory mechanisms to get these things under control. It's impaired by the typical Western diet, shocking. Immune homeostasis begins to take shape early in life through microbiome from your mother, breast milk, environmental microbes, etc. The low fiber and high fat content of Western diet changes the microbiome, decreases the production of short chain fatty acids. Short chain fatty acids are really, really important, and let's just leave it at that. That's what this is saying. And yeah, we use those clinically. We use those, as a supplement. But also why high fiber diversity is important for gut health in particular. Then here's psoriasis. It's an immune-mediated, chronic, relapsing, remitting inflammatory dermatosis triggered by a multitude of environmental and internal factors in genetically susceptible individuals. So that's everything. Treatment options, talking about the Th17 pathway, that psoriasis is more of a Th17, which is tissue damaging, rather than like an eczema or the itching. It's commonly associated with inflammation in other organs. IBD, the association is particularly strong. And again, it's just a little bit more inflammatory. Metabolites produced by the microbiome have the potential to modify this, capable of altering the balance between tolerance and inflammation. So again, we're talking about these regulatory T cells and short chain fatty acids, and even different, therapeutic probiotics that have been shown to have an effect on immune function and certain cytokine presentation and things like that. Then it talks about modulation of the microbiome. So clinically, this is what we do. We are taking probiotics, taking short-chain fatty acids, taking killers, taking different herbal things, antifungals, antimicrobials, antibacterials, antiparasitic things, and we're shifting this terrain. We're shifting this microbiome. Sometimes we're pulling seeds, sometimes we're pulling weeds, sometimes we're planting seeds, sometimes we're tilling soil, sometimes we're repairing the fence around the garden to keep the rabbits out. But all of this is important, and this is what we do clinically. And what it's saying is, how can it have an effect on the skin? Probiotics and acne. This is really, really good. I think that probiotics may also lower the glycemic load, which was going to reduce IGF-1 signaling, which is going to turn down mTOR signaling. And there's many other things here. I'm not going to go through them again, but it's basically showing that there's evidence to support this. Here's atopic dermatitis. Different things, different bacteria. Lactobacillus, bifido are the most commonly tested probiotics. They're the most common probiotics out there on the market. So that's not too shocking. And they're showing these different strains had these different results. Probiotics in psoriasis, etc. So the point is that if you have a skin condition, if you have eczema, if you have psoriasis, an autoimmune condition, if you have, really almost in acne, highlighted this paper, then focusing on the gut is really, really important. Now for you, your strains might not be the same as what's listed in this paper. These are large studies that look at just general associations, or they look at very, very specific associations to reduce the number of variables. But we can do stool tests, we can do gut permeability tests, we can do things to determine, just even your digestive integrity, and then we can put some priorities in place and target these things and shift them through different natural and alternative modalities like supplements, dietary changes, and things like that. So very, very cool. The gut microbiome is a major regulator of the gut-skin axis.